So for today's video, I'm going to describe aspects of the hyperbola, which is from section 7.4. So you can look at the chart on page 632. So the difference between how the equation is written for a hyperbola and for an ellipse is that the hyperbola, one difference is there's a subtraction sign. So here's an example of a standard equation for a hyperbola. X squared over a squared minus y squared over b squared equals 1. So there's one difference. There's going to be a subtraction sign. On the standard equations where the center of the hyperbola is at 0, 0, the a squared and the b squared are going to stay in the same spot. So here's one standard equation. The other standard equation is y squared over a squared minus x squared over b squared equals 1. So the difference between these two is where the foci and the vertices are located. So let's look at this example. Given this equation of x squared over 4 minus y squared over 10 equals 1. We want to determine what is the orientation of the hyperbola, or is it going to have branches that are going to open to the right and to the left, or up or down? So given this, it's x squared over, this is always your a squared, and then the second denominator is always your b squared. So a on here equals 2, b equals 5, and c we will solve for. So since a squared is under the x squared, it means we have a hyperbola that will look like this. So let me sketch it. The hyperbola will open to the right and to the left. And the transverse axis, or the major axes here, is a horizontal axis. So this is the transverse axis. And this is where the vertices and the foci are located. Again, A is the distance from the center. So these are going to have a center today at 0, 0. From the center to a point that's actually on one of the branches. So right here, this is one of your vertices, and it would be located at 2, 0. The other vertex is located over here at negative 2, 0. Then let's go ahead and solve for the value of c. So c squared is equivalent to a squared plus b squared. So c squared is equivalent to a squared plus b squared. So let's solve for c squared. So c squared is going to equal a squared, which is 4, plus b squared, which is 10. So c squared is going to equal 14. So c is going to equal the square root of 14. So this is the distance from the center to where the focus points are located, again on this transverse axis, which happens to be the x-axis for this one. So those ordered pairs will be over here. So the foci, one of the focus points would be located at the square root of 14, 0, and the other one would be located over here at negative square root of 14, 0. And this hyperbola here would have branches that open to the right and to the left. Let's do one more of this type of example. So given this equation of y squared over 8 minus x squared over 5 equals 1. So again, the order stays consistent in that this is a squared and this value here is always b squared. It's not like the ellipse where a squared was bigger, but this is always your a squared and this is your b squared. So since a is under the y-axis, it means a sketch of the graph would look like this. So this is going to have branches that are going to open up and that are going to open down. So on this one, the transverse axis is the y-axis. This is the transverse axis. When you have a center at 0, 0, then this happens to be the y-axis, or the equation for that is x equals 0. So on here, a is equal to the square root of 8, which would simplify to 2 times the square root of 2. B is equal to the square root of 5, and we will solve for C. So the vertices again lie on the transverse axis. So here's a vertex, which is located at 0, 2 square root of 2. And down here is another vertex, which is located at 0, negative 2 square root of 2, which is your value for A. Let's go ahead and solve for C. So again, the relationship that we can use is C squared equals A squared plus B squared. So here's A squared, which is 8, and B squared, which is 5. So C squared is going to equal 13, sorry. So C is equivalent to the square root of 13. This will be the distance from the center to the focus points, which again is on the same axis as the vertices. So the one focus point will be located up here, and the ordered pair for that would be 0, square root of 13. The other focus point is going to be down here, and that would be at 0, negative the square root of 13. Thank you.